Hey, what's up everybody? I'd like to welcome you to another audio programmer tutorial. And in this tutorial, I'm going to show you how to get started with using graphic controls in your audio plugin, including how to create sliders, labels, and buttons using C++ and the JUCE framework. These are the building blocks of your plugin's user interface, or what some people call the GUI or UI or GUI for short. And this is essential for how users can interact with your plugin. There are a few ways that you can get started with creating a UI for plugins using JUCE, and in my opinion, this is the easiest way to get started. First, we'll cover how to add UI components to your JUCE project. Then, I'll share some basics for organizing your components on the screen so your UI stays clean and easy to use. And finally, we'll talk about some simple customizations that you can use to start creating your own style for UI elements. Here's a quick demo of what we're building today. We're going to create a slider that's going to have a label called frequency, and we're going to create a button that is going to be able to go between two states, playing and bypassed. Be sure to check out the previous tutorials to catch up to where we are now, or download the project itself in the video description below. And if you find this tutorial to be helpful, please like and subscribe. It's a big help for us. And if you're curious about how to build your own plugins, be sure to check out our community, resources, and services at theaudioprogrammer.com. Without further delay, let's get started. All right, so here we are in our project that we did in our last tutorial where we played our first sound, which is a sine wave. In the sine wave class, you'll see that what I've done is I've changed the amplitude to 0 so we don't need to hear the sine wave the entire time because we're only working on graphics in this tutorial. So one thing to keep in mind is that we have two parameters in this sine wave. We have our frequency, which is the frequency of the sine wave, and we have the amplitude, which is the volume of the sine wave. And what we're going to do is create some ways that the user can control these parameters on the graphics side, but we're not going to connect the graphics side to the DSP in this tutorial. That's going to be the next tutorial. So we're only working on graphics for this tutorial. As I've mentioned in previous tutorials, a plugin has two sides. It has the plugin processor, which does the audio processing, and then you have the plugin editor, which is responsible for the graphics. For this UI design, we're going to create three elements: a slider, a button, and a label. So we're starting off with the slider right now. And as we can see from the JUCE documentation, slider inherits from another class called component. Component class is the base class for all visual objects in JUCE. And inside this component class, you have loads of different functions for doing things with any visual component with JUCE, like setting the visibility, putting one component in front of another component, getting the width and height, setting the bounds, how large or how small you want the component to be. There are loads of different things that you can do with this component class. And slider is inheriting from the component class, which means that anything that a component can do, a slider can do. First, let's create a slider. There are several different constructors on how we can create a slider, but we're going to use the simple one, which is creating a slider object without any arguments. Let's go to our plugin editor header file, and in the private section, we're going to create a slider. I will call this frequency slider. Before we go to the next step, just wanted to remind you about the way that components and visual elements work in JUCE. The way that it works is that we have a canvas, which is our parent component. That is our audio processor editor. If I hover over audio processor editor, we can see that this is a component class, which is a visual class in JUCE. So that's just this blank canvas that we see here. The next thing that we need to do is we need to declare the frequency slider as a child component of the audio processor editor. The way that we do this is by going over to our plugineditor.cpp, into our constructor, and then using the special command from the component class called addAndMakeVisible. This is going to make the frequency slider a child component of our plugin editor, which is our canvas. So the next step for getting this frequency slider to show up on our screen is to find a way to describe where we want it to display and how big we want the frequency slider to be on the canvas. The way that this is normally done is in the parent components method called resized. So we have this resized function here, and this is where we would set out any child components and where we want those to be displayed on the canvas. Now, there are a lot of different ways to do this. There is what's called a flex box or a grid. You can use this command called setBoundsRelative. There are many different ways to do this. The way that is the most simple is using this setBounds function here that takes 4 arguments: the X position, the Y position, and then the width and the height of the component. So let's go ahead and try that now. Let's go ahead and build this. And here we can see that we have our slider displaying on the screen. So as we can see, the slider is currently displaying horizontally across the screen. And one of the things that I can show you from the JUCE documentation is that you can change the way that the slider style is showing. So you got linear horizontal, which is what we currently have. You can also display it vertically, and there are a lot of different ways that you can do this. But let's just go for a linear vertical style. All right, so in this case, I've used the slider function called setSliderStyle to describe the style that I want as linear vertical. And as you can see, this is displaying properly as a vertical slider. This part here may look a little bit verbose for beginners, so I just wanted to take a moment to describe how I got here. So we have JUCE, we have slider, which is a class within JUCE. We have slider style, which is an enum inside the slider class. And then we have linear vertical, which is the type of slider style. Now let's show how that works on the JUCE codebase side. So here we're going to go into our JUCE slider class. And then we have namespace JUCE. So JUCE is just the name of the library. Scroll down a little bit. Then inside of this namespace JUCE, we have our class called slider. So far we have JUCE, slider, and then we have the enum slider style, which is inside the slider class. And then inside this slider style, we have our different types of sliders. And in this case, we're doing linear vertical. So that was something that took me a very long time to get the hang of when I was first starting out. So hopefully that was helpful for some of you. Now let's adjust the set bounds to get this slider into the middle of our screen. As you can see, we have the current size of our canvas set to 400 by 400. So to get the middle of those points, what we can do is we could use the special component command getWidth to get the width of our component. We could divide that by 2, which will give us the middle point of our canvas on the x-axis, and then we'll subtract 50 pixels from that because we're going to make the width of our component 100 pixels. Then we're just going to do the same thing for the height. So we could do get height, which will give us the height of our canvas in pixels. We'll divide it by 2, which gives us half of that, effectively putting us at the middle of the screen. And then we'll subtract 100 pixels from this and then make the height of the slider 200. Let's go ahead and build this. So now you can see that our slider is relatively in the middle of our screen, except the text box is now skewing it off over to the right. Let's see if we can change the text box position so that the slider shows up directly in the middle of the screen. For this, we can use the function inside the slider class called setTextBoxStyle. This takes 4 arguments. The first one is the text entry box position, and that is a enum that's inside the slider class where we want the text box. In this case, we'll put the text box below. The next argument is if we want the text box to be read-only, or if we want the user to be able to double-click into the text box itself and change the value. And then we have the box width and box height. So let's go ahead and put this in the code now. All right, so now we've used this function setTextBoxStyle. We've made the position for the text box to be below the slider itself. We're going to make it only read only, so the user cannot click into the text box itself. Then we'll make the width and the height 100 by 50 pixels. Let's see how that looks. As you can see, now the slider is perfectly positioned in the middle and the text box is below. Okay, let's say we wanted to change the range of this slider. Currently it's going from 0 to 10. We can see that we have a load of decimal places after the decimal point. So we can change this using the set range function from slider. So we say frequency slider set range. We'll make the minimum 0.0, the maximum 1.0. And then there's a third optional argument, which is the step size. So in this case, I'll make it hundredths, which is 0.01. Let's go ahead and rebuild. As we can see, now we have the step size going in 0.01 increments, hundredths, rather than all those decimal places. So that makes it look much neater. And it goes from 0 to 1. And then I've taken the box width and height and I've made that a little bit smaller so it looks even cleaner. All right, next let's make a text button. And as we can see in the inheritance diagram, that text button inherits from a much more simple class called button, and it allows us to have a button with a little bit of text in it. And here there are some different ways that we can construct this text button, and we're just going to use the most simple one, which is declaring a text button without any arguments. Here we are back in our plugin editor header file. And I'm going to just create a text button, and we will call this play button. Now in the constructor in our CPP file for the editor, let's go ahead and set some initial button text. We'll just set it to something like playing. Then we need to consider if we want this play button to just change state when the button is actually pressed down, or if we want it to change each time that the button is clicked. In this case, we're going to set it to change every time the button is clicked. This is using the button function set clicking toggle state, and we're going to set this to true. Since this button changes its state each time that it's clicked, we want to set some type of initial state to let the button know whether it needs to be on or off when it initially starts. Let's go ahead and set it to on using the function setToggleState. There's a second argument that this function takes of whether the button should send out a notification elsewhere in the application if the button has been clicked. In this case, we're not going to worry about that, so we're going to set this to don't send notification. Next, we want to describe what we want the button to do when it is clicked. Now, there are two ways that this can happen. One way is using what's called a listener, where there's another place in the application that is listening for when the button is clicked and then calls a function called a callback that describes what happens when the button's clicked. A much easier way to do this is using what's called a Lambda. Think of a Lambda as a very small function that doesn't warrant needing to create a whole different area in code. What we can do is use this button function called onClick to describe a Lambda that will define what happens when the button is clicked. Now, if you've never written a Lambda in C++ or in general before, I'm going to show you how to do one right now. The way that you start is by saying play button onClick, then there's an equal sign, and then you have these square brackets. Now, what you need to do is pass in any data that you need access to into the square brackets. The data that we need access to is the play button. The play button is part of this class called Audio Processor Editor, the class that we're currently in. Okay, so play button is a class member of this class that we're currently in called Audio Processor Editor. There's a key word to refer to the class that we're in, and it's called this. Okay, so that's a pointer to the class that we're currently in. And that's what we need to pass in order for us to have access to this play button inside this small function that we're writing. And then we have some regular parentheses, braces. Then we need some curly braces, and we need a semicolon at the end of the curly braces because it's a function. And then inside here, we're going to change the state of the button when it's clicked. So next what we can do is find out the state that the play button is currently in. The way that we can do that is declare a local variable. We'll call this const bool is playing equals play button get toggle state. Then what we'll do is we will use that state to say if the button is on, then we want it to display the text playing. If the button is off, then we want the button to display the text stopped or bypassed. So we can do this by saying play button, set button text. Here we can use shorthand if. So we'll say is playing. If it's playing, then we want the text to say playing, or else we want it to say bypassed. Now let's not forget to add the play button as a child component of our plugin editor class. Very common mistake to miss this step and wonder why the button is not displaying. Here I've set some bounds for the play button using the same technique that I used for the frequency slider. Let's go ahead and build this and see what we got. Now we have a button that says playing, and when I click it, it should change to bypassed and back to playing. So it looks like this button is working properly. Now, wouldn't it be cool if we could have the button green when it's playing and red when it's bypassed? If we go back to the documentation for TextButton, we have these color IDs which allow us to use different colors for the states that the button is in. So we have a button color ID, which is when the button is off, and a button on color ID when the button is on. So let's go ahead and use that to change the color of our text button. The way that we could do this is using the component method called setColor. This takes two arguments. The first one is the color ID, and the color ID is the enum from the TextButton class that I was talking about just a moment ago, where we talk about which aspect of the button that we're trying to change the color on. Then the second argument is what we want the new color to be. Let's go ahead and use that. So here I've created two new function calls for setting the color. The first one is for the button on color ID when the button is on and playing, and I've changed that to green, and then the button off color ID, which is going to be red. And once again, notice the nomenclature here. You have JUCE, which is the library, TextButton, which is the class, and then an enum within that class, which is color IDs, and then the actual aspect of the button that we're trying to change. So that's how that works. Let's go ahead and build this. And now we have a button that is green when playing and red when stopped. Another thing to quickly notice is that I didn't put these set color function calls within the onClick Lambda. So it doesn't need to define what the colors are each time that the button is clicked. So that's just in the constructor. The only thing that needs to be defined within the onClick, that is when the button is clicked, is what the state of the button currently is, and then to set the button text depending on what the state is. All right, so for the last part of our tutorial, we're going to talk about labels. So what if we wanted this slider to control the frequency of our sine wave eventually? Well, first thing we'd have to do is change the range of the values here, but that's beside the point. What if we wanted to have a label that labels this slider as frequency? So the way we do this is using the label class. So label class is a pretty simple component class in JUCE. So you can see here that the constructor takes two optional arguments. We know that these are optional because of this equal sign here. And this is a component name. So that's just a name if we wanted sometime in code to do something to the label, we can refer to it by a name that we give it. And then this label text is actually what displays on the label itself. So let's go ahead and create one of those now. And the way we could do that is just calling JUCE label. And we'll call this frequency label. And here I'll give it 2 arguments. The first one we will just call frequency label. So that's just the name of the component itself, not actually what the label is going to say. And then the second part is actually what it's going to say, which we will call frequency. And now we just need to add the frequency label as a child component to our current component. And now I'm setting the bounds of the frequency label inside resized to set the position. Let's see what we got. So as you can see, the frequency label is showing up above the slider, but you can see that it's a little bit off center, and I'm going to show you why. So one little trick that I like to use when I'm trying to align labels and align components is changing the outline color ID. This will help you figure out what's happening if you're finding that you're getting misalignments in your components. So as you can see here, frequency is justified to the left on the label component, which is larger than the text, obviously. So we can see that the label area is centered on the slider, but that the text itself is justified to the left. So we can change this using a method called setJustificationType. So the way you do this is frequency label, setJustificationType, then JUCE, justification, centered. Now we'll rebuild. And now we can see that that's centered. And what I can do is I can remove the outline color now if I want to. And now we have frequency that's centered on top of the slider that it's associated with. And there you have it. One thing to note is that there are several ways that you can create user interfaces with JUCE. And to me, this is the easiest for beginners. And in the next tutorial, I'll show you how to connect these components up to the sine wave that we created earlier in this series. Until then, happy coding, and I'll see you next time.